This conference will now be recorded.
Hi everyone, my name is Rudra. So I have been working in this particular field for more than 6 years. Okay, and I have experience in synthesis, PD, and STA prospects, and a little bit basics on the RTL integration as well. So where I think I might be able to handle your batch as well. So I'm not sure about that. So that gets just in the flow. Okay, so this is the brief info introduction about myself. Now, so I'll just go as like an simple way. That is like first, what is VLSI? Instead of telling what is VLSI, first is what is IC? What is an IC? Guys, please be interactive. What is an IC?
It's an integrated chip.
Okay. What is the purpose of an IC? Or let's say, why did we invent that particular IC?
Large number of transistors placed on in single chips, it will
Right.
be reduce the size.
Yes. So in IC, we say is like it's an integrated chip. In that means like in a smaller area, we are going to be implementing multiple transistors to perform the logic which we require, or let's say the functionality implementation. Correct? Now, multiple transistors. So the main purpose of developing this particular IC is to reduce the area of that particular function. Correct? If I use multiple transistors and wires, the circuit will be big. To reduce that particular area, we are using this particular IC. Correct? Yes or no? Guys, here I'm not going to be shouting, or here I'm not going to be scolding for wrong answers. Though if it is a wrong answer, please try to respond such that we can be able to discuss more things. Okay, so my only one request is like, please try to unmute or please try to message in the chat and be interactive. That is what my major request is.
Okay, sir.
So we are developing this particular IC as first term is like to reduce the area. Okay, and the second reason is when you have the distributed placement of that particular transistors, or let's say if the logic is like distributed in different regions of that particular circuit, so then what happens to the power consumption? Will that also be having any effect? Let's say, like say in simple terms, the power distribution, as the area is more, I need to be focusing more on that power distribution as well.
Yes, sir.
So related to power, and also, okay, and also timing. The time taken for the data to be propagated, or let's say for that particular signal to be propagated from one input to the other output, or sorry, one from one output to the next input. So start point and end point. Okay, from the start to the end, what is the time taken? So by keeping all these particular three categories in mind only, we are going to be developing the IC. Okay, majorly is like these three terms: area, power, and timing. Okay, of that particular internal working of the circuit, we will try to develop this particular IC. Okay, now, so according to the number of transistors, okay, according to the number of transistors implemented in a single area, we are having different types of ICs, correct? Based on the number of transistors. That is SSI. Heard about these terms?
Yes, it's small scale integration, medium scale integration, large scale integration, and very large scale integration. And we have VLSI as well.
Right. And there are keep on going the terms like ULSI, GSI, like that, the terms are getting increased. But as the terms, or let's say, as the number of transistors are getting increased by one also, but we say in common is like VLSI industry only. Correct? You're not terming it as like ULSI industry, you're not terming it as GSI industry. We are just stopping there with the term VLSI only. Why is the next question we'll see. So in SSI, that is small scale integration. What is the range of transistors?
10, 100. Okay.
Okay, 10 to 100. So similarly, what is the transistor range for MSI? 100 to 1000. Okay, LSI transistor ranges 1000 to 10,000. VLSI is okay. So if it is having greater than 1 lakh to that particular 10 power 7, we will be terming it as ULSI, and greater than 10 power 7, we will be terming it as GSI. That is like 1 million, right? 10 power 6 to 10 power 7 and greater than 10 power 7. Okay, so on the basis of the transistor count, we are having these different categories. Now, let's say for example, what does is an SSI circuit will be having? If we are having 100 to 10 to 100 transistors in that particular range, what is the circuit you are going to be having? Basic gates, correct? And gate, or gate, so like that you will be developing those particular gates, and those gates will be coming under the category called as SSI. Okay, so similarly when you are going for MSI, LSI, VLSI, it will be like processors, flip-flops, full adders, half adders. So like that, according to the number of based on the circuitry, the division will be provided. Okay, so let's say for full adder, okay, for that particular developing of full adder, so it is going to be having some AND gates, or it is going to be having some muxes, or it is going to be having OR gates. So like that, it might have different gates available inside that particular circuitry itself. Yes or no? I'm just giving a random example. So full adder, I think you all know, like it will be based on the NAND gate and AND gate implementations. So just for example, I'm just trying to say is like it will be developed based on the basic gates only. Am I correct? Any circuit which are going one level up, those circuits are developed based on this particular universal gates only. Yes or no?
Yes, sir.
Right. So that means when we are going any level up, okay, so those are levels are implemented based on the default let's say basic information only. Okay, so that means when we are considering VLSI, and those will be like processors, and those particular processors are developed based on this particular SSI cells, MSI cells, and LSI cells. It's not, let's say, like internally also we will try to integrate them. Okay, we will use that particular existing cell information to develop that particular circuit which you are trying to form. It's not like we are going to be using the transistor logic. No, we are not going to be implementing based on the transistor logic. Okay, if you are going to be working on the transistor level, or let's say stick diagram information, then we will be saying that as an analog designers. Okay, so as analog designers, we will try to create the basic gates, or let's say universal cells which you are going to be using it in your designs. We are not going to be working, again I'm repeating, we are not going to be working in a transistor level. We are going to be working in an chip level only. Okay, or let's say block level. That means we are going to be using the existing circuitry to develop that particular circuit. Okay, bigger circuits. Okay, now next, so let's say like in that particular VLSI only, if you are integrating more VLSIs into single circuitry, we will be terming that as ULSI or GSI. Like that we will be having it. Okay, now, so according to the usage of that particular circuit, okay, according to the usage of the circuit, we have majorly is like two categories. Sorry, according to the usage of the circuit, we have two types of designs, that is ASIC and SOC. How many of you are familiarized with these terms ASIC and SOC? What does this mean? ASIC mean?
Application specific integrated circuit.
Right, perfect. SOC means
Single on chip.
system on chip.
System on chip, sorry.
Okay, right. So when we are telling ASIC means, as you said, application specific integrated circuit. So that means like I'm going to be creating a circuit to work only for a particular function, or let's say I'm going to be developing a chip only to work for a particular function. Okay, that is, for example, a sensor. If I come in, as soon as it senses me and it should allow me in, there is no usage, other usage of it. Okay, it should sense any person is coming, open the door, and it closes the door automatically. no other person. Okay, that we will be terming it as ASIC, application specific. Now the next is like SoC, that is system on chip, where we are going to be integrating multiple ASICs to develop one big circuit. For example, your laptop, or for example, your phone. So those are like your system on chip related circuits. That means multiple application specific integration are integrated to form that particular motherboard. That is your SoC. Okay. In our particular phone, when you consider display, it is just used to turn on or turn off, or let's say view the content of whatever we are trying to pass the data to it. Okay. So that is the only difference. Okay. ASIC is like it is used only for a particular task, whereas SoC is used to perform multiple tasks. Okay. Now, why did you choose VLSI? Why did you choose VLSI? Any reference, or you want to get into core, or you want more package, or whatever it is? Why did you choose it?
Wanted to get into core.
Perfect. Okay. Next, you can see it nearly 16 people joined, but I'm receiving only one reply.
Core and more package.
Right. So, if in this particular VLSI, or let's say this VLSI, we can also term it as an IT hardware. Okay, so we are going to be working with different CAD tools to get our particular task done. Okay, so it's not like again we are going to be working here any physical related. We are going to be working here with respect to the software tools only available in the industry. Okay, so the major companies will be like the providing vendors are like Synopsys, Cadence, Mentor Graphics, and there are multiple. Okay, so when it comes to our PD perspective, or let's say backend, right? When it comes to our backend, the supporting tool vendors are Synopsys and Cadence. That will be the major we use for physical design. When it goes for front end, they might be using is like Spyglass, uh, and they will be providing Mentor Graphics, Xilinx tools. So like that, it will be having a variation according to their usage. They will try to use different tools. When it comes for us, it will be having is like Redoc, uh, and Synopsys and Cadence. This will be the major. Okay, now that we will see what all tools we are going to be using and everything. Now the next task is ASIC flow. Okay, so as we I probably think so like everyone has chosen physical design here, right? I hope so everyone. Okay. So transistor level playing, we have two categories. That is like one with respect to the analog designing, and second is like near to that silicon manufacturing. We will be working with respect to the transistor level. As a PD engineer, you may or may not work with respect to the transistor level. Okay, right. Now the major difference is like here in this particular IC development. Okay, this PD or let's say PNR, whatever we are doing, right? We are going to be developing an IC. Okay, that means you are going to be creating that particular, or let's say that for that working of that black module available in your laptops or in your phones, that black box you see, right? So that internal circuitry you are going to be developing here. Okay, by using the CAD tools. So that is what IC, or let's say IC development, that's what we are going to do. When it comes to FPGA, okay, it's like an embedded system. That means you already have the circuits. You are going to be again passing, or let's say you are going to be writing a code to make that particular FPGA working according to your requirement. Field programming languages, right? So that is the major difference between FPGA and ASIC. So here I'm going to be developing that particular chip. In FPGA, that particular developed chip to work along with your situation, you have to provide it. Okay, what will be the timing required for the data processing? Everything you are going to be providing it in the FPGA. Here I will develop it and I'll just pass it. That is the difference. Okay. Now, coming back to this, our particular flow, that is ASIC. Okay. Okay. So now coming back to our particular developing of chip case. Let's say when you want to, okay, before going into this flow, when you want to buy a phone, what all you will try to search? What will be your requirement? When you want to buy a phone, what will be the requirement? RAM, storage, next, performance. So my first and foremost is like when you are a gamer, okay, let's say for example, when you are a gamer, you will Avinash, presently it's like let's cover the theoretical concept of the goal, that is like physical design demo, and at the end if you are having any let's say like administrative questions, let's say like timing, fee structure, or let's say duration, or let's say which particular job perspective is good, that will be discussed at the end. Okay, right, because we are going now is like theoretical, we don't want to mix up with that particular task. Okay, those are two different tasks, so we'll cover up one by one. Right, so now coming back to our concept, that is like first point is like when you are a gamer, right? So you will just first look for the refresh rate of your display, and next you will be looking for your whether it is an octa core, that is like processor, is it a latest processor, and it is an octa core or a quad core, or whether it is having a battery backup, all that you will try to look. and along with that the internet supportive speed, that is like different bandwidths also you will try to look. Okay, when you are a gamer you will try to look for this. Let's say you want to get into photography, then you will try to look again for the refresh rate. You will look for the camera, how much megapixel it is having, what will be the internal processing unit of that particular camera, all that according to your usage. That means you are seeing that particular filtering switches, correct? That means even when I'm developing that particular chip. Okay, so when you are trying to develop any application specific related chip, my first and foremost required values will be the requirements. Okay, the first and foremost step will be the requirements. So based on this particular requirement only, I'm going to be developing that particular chip, or let's say requirements or idea. So whenever you want to buy a phone, and if you go with a blank idea, okay, the first and foremost what that particular salesperson will ask you, what is the purpose of that particular chip, or let's say what is the purpose of buying the phone. That will be the first question asked. So that's why I said it's like either idea or requirements. If you know I need this particular specifications, then you are going to be providing that particular specifications directly, or you will just pass an idea. Once the idea is passed, what will be the next step the person will try to do? Or let's say when you are trying to search for that particular phone based on your requirements, what that Amazon app or a Flipkart app or whatever the app you are using will try to do for you? Guys, did I ask any tricky question? Cost, right? So next is like it will try to, based on the filters you applied, it will try to display you some set of options, right? Different phones, different manufacturers, everything it will try to provide you. And based on how you want, you are going to be again you are going to be ordering it, right? So that means, right, they convey the features of each and every particular device. That means like they show you different options now, right? So that means like they will try to develop in a flow basis now. Let's say from the slow range, or let's say from that particular low range to the highest range, they will try to tempt you now. That means like they will try to develop a flow. So now similarly here also, based on the requirements or idea, okay, let's say I'm going now with respect to a language basis, or let's say scripting, or let's say HDL. Okay, I'm going to be converting that. So that particular requirement or idea, I I have to convert it into a flow now. Okay, I'm going to be developing a flow chart. Okay, based on that particular requirements or idea, the next step will be the flow chart. So how I need to implement, okay, such that I can be able to satisfy the customer. The flow has to be developed. Okay, in this particular flow development, okay, what they will try to have is, let's say in your phone, what all modules you require? Camera module, network module, display module, storage module, internal processing modules for clocking, all the different modules I need. Okay, for that particular module, what will be the power consumed? that information also this particular person will try to perform. In other terms, this flowchart development, I'm going to be making it as architecture designing. That means your complete design now, or let's say your requirement, will be converted to an let's say, how can I say this? Presentation format. Okay, so that means I will be able to get to know from this particular architectural designer where each and every module is going to be placed. That means camera, network, storage, display. If there are any modules, according to that particular modules, where it is going to be placed, that information will be known. And also the power information. And as we say, right, I want is like more refresh rate. As I'm telling more refresh rate, the speed of the working, okay, the speed of the working, that is your timing information, will also be provided by this particular architectural designer. Okay, at which speed that particular data has to be processed, what will be the power consumed by that particular module, that information also will be known from this particular architecture designer. Okay, clear so far? Is it clear so far for everyone?
Yes, sir.
Right. Okay, so that means I came to know which modules I have to use, right? Camera module, network module, display module, and like that, storage module. I came to know which modules I have to use. Now, according to this particular module, the internal information of that particular also has to be extracted. That is like what information should be present inside the camera module, how many megapixel. Okay, according to the megapixel, which particular DSP module has to be used, that information again has to be represented. So this architectural guy also will try to provide the internal information of this camera also. That means this particular megapixel has to be supported, and according to that particular megapixel, what is the processing units to be selected also, this architectural designer only will try to process. That means all the overview information, okay, all the complete overview information will be provided by this particular architectural designer only. Okay, so he is the main person. So that's why this architectural designer will be of highly experienced engineer. Okay, he will be having a highly experienced engineer where he can be able to handle multiple teams. Okay, the main person. Structural information of the chip. Okay, now I have got to know which modules has to be used and all that particular information I came to know. And now what will be the next step? What will be my next step?
implementation.
The next step after architectural design will be, that means once I got that overview information, the next step is making that particular each and every module as a behavioral code. Creating a behavioral code for the logics. Okay. Now, so this behavioral code means what we have. What are the behavioral codes? HDL languages like creating netlist, that is like Verilog code, system Verilog,
UV.
PHP, right? UVM, that is like verification purpose. So SDL. So like that, we will try to create it. And the persons who are creating this particular behavioral code are called as RTL designers. Okay, these people are called as RTL designers. Okay, and once I have written the code, what will be my next step? Let's say if you are writing any script, what will be the next step? If you are buying a product, what will be after buying the product, what will be the task you will do?
Taste it.
Sorry,
Taste it.
testing, right? So, or let's say verifying. So is that particular phone following my requirement or not? That will be our next step, right? So the next step is verification. Here, functional verification. So that means the return Verilog code is following my requirement or not. Okay, the return Verilog code is as per the requirement of the uh, requirement, as per the requirement of the customer or not. That is what we need to verify it. Okay, by creating multiple test benches. Okay, by creating test benches, we are going to be using that particular functional verification. Okay, so this again I'm telling, the whatever the flow I'm explaining, right? This is the complete flow required for the manufacturing of the chip, where you might be working from a certain stage or you might be working from the RTL to GDS also. You will be hearing, right? So from few of you might be experienced, I guess so. So if you are experienced, you will be hearing a term called as RTL to GDS, netlist to GDS. So like that, you will be hearing few categories. Okay. So that means based on the logic information, you will be working at that particular equivalent stages as well. Okay. It's just say like flow knowing is important, but knowing each and every stage is not important. Okay, how the chip is manufacturing, what all steps are there, knowing is very very important. Okay, so that's what we are covering right now. So now, after functional verification, what is the next task?
Physical design.
Okay, so Now, before going into physical design, so as I was telling, right, there are some requirements like area, timing, and power. So that means for each and every module, or let's say for each and every separate ASIC of your phone, there will be different frequencies required.
Yes, sir.
Yes,
Yes, sir.
right. So as I require that particular difference in the frequencies, I need to develop the timing constraints. Okay, I need to develop the let's say like what will be the requirement for each and every module, the timing that I need to develop. Okay, and coming to the second point, that is like the code which we are having right now in this particular Verilog or system Verilog, we are having is like a behavioral code information. So by using this particular behavioral code, will I be able to physically implement it?
No.
No, right? So what should I do here is convert this particular behavioral code to a gate level information. That means this particular behavioral code present in the netlist, I should convert each and every logic to its equivalent SSI logic or MSI logic. Okay, if it is having memory circuits like SRAM, DRAMs, you would be hearing, right? So if there are of bigger processing units or bigger storage units, I might use LSI also. Okay, if there are 8 bit processors, or if it is having bigger memories, then I might use this like LSI also. Okay, according to that particular logic present in the netlist, I should convert that particular logic to the equivalent gates which are already developed in this particular stages. Okay, so that means we are doing is like an incremental project by usage of the existing circuits. We are not going to develop anything new, already implemented. We are going to be creating new or implementing new logics to it as well. Okay, so engineer main role is, right, uh, create error and fix that error. That means like whatever I do in the design, you find out an error and you will try to fix it. Whatever you do, your friend will try an error and he will try to fix it. That is the major role of engineering. That's what we are going to do as well. Okay, nowadays it's like, as you know, that it's down. We are doing is like incremental projects only. That means advancements only we are trying to performing. New projects are still in progress. Okay, so it will take some time. I'm telling now it. Now, functional verification. Okay, after this particular functional verification, so this test benches and everything, I'm performing it based on the existing behavioral codes, right? So once I've developed this particular chip in a physical format, okay, if I develop this particular chip in a physical format, then what will happen? Will I be able to test that particular chip with respect to the test bench which I have used for Verilog?
Yes, sir.
No, right? If I use that, sorry, go ahead. Someone is unmuted. Is it Balaji? Subbu? Subbu, could you please
Yeah,
mute yourself? Is it you speaking or is anyone else?
I'm Subramaniam from Tirupati.
Okay. Because I can hear someone speaking, I thought it's you, as yours was unmuted.
Yes, sir.
Okay.
Okay.
Background noise was coming. That's why. Okay. So now in this particular functional verification, after this particular functional verification, we can say a single stage called as RTL sign-off stage. Okay, where in this particular RTL sign-off stage, we have is like multiple tasks running in parallel. We can say is like linting, CDC. Guys, if anyone is unmuted, please try to mute. I can hear some background noises. Please unmute only when you are having questions or when you want to answer something. Okay. So linting, CDC, RDC. So CDC means clock domain crossing. RDC means reset domain crossing. And next, UPF, where unified power format. You can also say it as a conformal low power stage. So this is, I'll tell you in detail. Okay, and after this, you can say one more stage is like, sorry, I'll just write down this flow, and after that, I'll explain it again. Okay, so now I'll come from here, RTL sign off stage. So that means like in this particular sign off stage, I am verifying that all the constraints of which I have written so far, or let's say whatever the information I have provided so far is accurate and there are no issues in that particular netlist. Okay, that is like we are verifying once again. So in this, I have, as I said, we are having different stages. Linting. So linting means we are verifying that particular code, whatever we have written in this particular RTL design stage, whether they are having any syntax errors. Okay, in this particular linting stage is like we are verifying if there are any syntax errors, and also we are making sure that particular code whatever we have written is convertible to its equivalent gate information, that we are verifying in this particular linting stage. Okay, syntax errors and also the code conversion to the equivalent gates, that will be verified in this particular linting stage. And the next is like CDC. CDC means clock domain crossing. So for example, your data processing, okay, let's say you're capturing a data, right? That particular data captured, okay, the data which you are capturing will be stored into your memory, correct? Whatever the data you, as soon as you capture it, it will be stored into the memory. Yes or no?
Yes, sir.
Right. So when you are trying to store it, is the working frequency of the camera and the working frequency of the memory, will it be same or different? It may or may not be, right? Yes or no? Okay. So let's say like the data which you are trying to capture through the camera is working with frequency of 100 megahertz, and the storage which you are trying to perform is working at a different frequency. Let's assume like 50 megahertz. So my data is getting propagated from one frequency to another frequency. Then by default, will that particular data be stored properly? Okay, let's take another example. That is like there are two types of students now. One is like as soon as you say it, he will try to capture everything in a faster method. And similarly, there is also one more person is like, if I go in the speed, he might not capture everything. Okay, one is like fast worker and the other one is like slow worker. Okay, so when you give the same when you want the passing the information from fast worker to slow worker, what will happen? What will happen?
Confuse or some data
Hmm,
loss.
right, confusions or data loss will happen, right? If that means I should make that particular path to be working at the same phase, only then they can be able to map, right? There will be, I want to cover let's say remove that confusion. To remove that particular confusion, the first thing I have to make sure like both are going to be working at the same phase, or I have to provide a time gap between them, fast worker and slow worker. Only then I can be able to map that particular data. Okay, this is one case. And now there are enemies. Okay, let's say both the fast workers are enemies. Will the data be passed from one worker to another worker? Yes or no? Okay. So let's say like synchronous clock domains and asynchronous clock domains. Okay. Synchronous and asynchronous clock domains. So when the data is getting passed between asynchronous clock domains, CDC related help has to be required. Okay. Data passing between asynchronous clock domains. Okay, so similarly, if the data is passing with respect to different frequency of the clock, we say is like CDC. If the reset signal is getting passed between different groups, then we will be saying it as RDC, reset domain crossing. Okay, so the next is conformal low power. So when we are talking about conformal low power, reduction techniques to reduce the Okay, or let's say reduction techniques for power consumption. Okay, reduction techniques for power consumption will be created by using this particular conformal low power. Okay, so all this which we are discussing is done by different tools. You will not be creating all this. It will be already developed and you will be using it, verifying it, and if you are seeing any issue, you will be reporting to that particular equivalent team. That's why you have to get to know what is the flow. Okay, so now coming to the next case, that is timing constraint development, where frequency for the working of the design and different delay values will be set. Okay, so when we go to the practical, right, or let's say theoretical, we will try to look what is the internal information of this particular SDC and also the internal information of this particular UPF. This is required. Okay, so when we go to the advanced concepts, we will be covering these two concepts as well. Okay, conformal low power and timing constraints. That means we will not work with respect to the tools, but what the internal information of that particular file will be there and how it is getting developed, that we will just go through a quick view. Okay, because we have to know that particular concepts, so that's why we have to go with a quick view concept. Okay, so the next is DFT. So what does this DFT will do? I hope so in your engineering you would have heard few concepts related to DFT. What is done in the DFT?
I think behavioral code and physical designing are suitable or not.
So here you have heard about few concepts like ATPG, JTAG, stuck at 0, stuck at 1. Like that we have heard few concepts during the engineering, right? Yes or no?
Yes.
Right. So those required parameters, or let's say modification in the netlist if required, will be done in this particular DFT. Okay. So ATPG, JTAG, stuck at 0, stuck at 1, and also this particular DFT persons will be able to give idea about the failures. Okay, functional failures after the development of the chip. Okay, functional failures after the development of the chip will be known by using this particular DFT persons. Okay, so functional verification is done during your initial case, but later on by using this particular various DFT structurings, you will be able to verify your chip. Okay, clear now. So DFT, where insertion of scan chain will be done. So while there are two stages here. Okay, so this DFT can be provided after synthesis or before synthesis. it in any level you mention, that is correct only. Okay, this DFT can be mentioned before synthesis or after synthesis as well. It is correct. Okay, because what will happen is, once we get this particular Verilog code, right? As soon as we get this particular Verilog code, we will try to verify it, and once that particular verification is successful, we will convert that particular behavioral code to a gate level netlist. Okay, in this particular synthesis stage, conversion of behavioral code to gate level code will be implemented. To gate level implementation will be done. Okay, so conversion of behavioral code to the gate level implementation will be done, and after that, okay, this is one level, and after that we will use this particular updated code. Okay, whatever the insertion is done, we will insert that, and again we will try to do synthesis again. So that's why we can either implement is like DFT, synthesis, or synthesis, DFT, and again there will be synthesis. So that's why before or after this particular synthesis you can mention the DFT. Okay, because, and one more point to be noted here is this DFT. Okay, this DFT will be working at each and every stage. Okay, this DFT will be working at each and every stage parallel to you after the synthesis. Okay, at each and every stage after the synthesis. Clear? Is it clear so far? Now, so here we will be discussing again, I'll repeating, we are going to be discussing in the advanced, that is conformal low power, timing constraint development, and also synthesis. Okay, so in synthesis also we have a subflow. Okay, we have a flow for synthesis also, that is, first step is analyze, elaborate, and compile. Okay, and what all checks to be done, that all we will try to discuss it during the session hours, that is advanced topics, what all checks we need to do such that to move forward, that we will try to perform during the advanced concepts. Okay, once this particular synthesis is done, you will try to perform as physical design. Physical design. The next is sign off. So where we will try to verify again. Okay. I'll just write down the terms which we will be discussing during the advanced topics. Okay. Physical verification. And the next is power, LEC. And there are multiple other checks as well. I'm writing down only few. So in here, we will be discussing about STA, physical verification as well. and after sign off we have is like chip to be manufactured, and we will try to verify it. And if it is successful, we will provide it to the customer. Okay, so the concepts which we are going to be discussing in advanced topics is synthesis, physical design, sign-off stages, STA, physical verification, and conformal low power and timing constraints development. Okay, these are the concepts which we are going to be covering. And now coming to the next concept, that is physical design. Okay, now again I'm asking any questions or any doubts you want to ask. Yes, please try to respond. Any questions or any doubts? Can I move forward? Okay. So our particular next stage is physical design. Okay. So in this particular physical design, okay, in this particular physical design, we have is like different flows. Okay. One is like flat level design. Based on the logic, okay, based on the logic, we have different namings. That is like flat level design or hierarchical design. Okay, based on the logic, we have the names is flat level design and hierarchical design. So when we are telling flat level design, that means the logic is less, and there will be only one person who is going to be handling from RTL to GDS. Okay, based on the logic, if the logic is less, only a single person is going to be handling all the topics, or let's say all the concepts, by taking the support of the equivalent engineers. When it looks from the outside, it will be working as a one person only, or let's say one team only, but equivalent engineers will be allocated. Okay, the next task is hierarchical design. That means when I have huge design, let's say like for your phone, multiple teams will be working. Camera module, separate team. Network module, separate team. Storage module, separate team. So like that, different teams will be working to develop one particular chip. That is called as hierarchical design. Okay, according to that, your netlist will be divided, verified, and then it will be provided to you. Okay, as we are dividing that particular logic into small logics, we also state it as block level. Okay, each module division is called as a block level as well. Okay, block level implementation, top level implementation. Okay, like that you will be hearing. Now, okay, now the next topic is, okay, flat level design, hierarchical design, and based on the logic we have divided. Now the physical design flow. Okay, physical design flow, that is import design, First stage is called as design planning or import design stage. Next is floor plan, power plan, placement, CTS, and routing. Okay, so this is the flow of the physical design. So now in this particular flow, the first stage is design planning. So in this particular design planning stage, we are going to be deciding, okay, we are going to be designing how the logic has to be implemented. That means, okay, so in this particular stage, we will be able to get to know how much area required for that particular module. Okay, according to that particular module placement, okay, according to the module placement, I will be also knowing the shape, which particular shape has to be implemented for camera, whether L shape or U shape, or whether it is an X shape, which particular shape I want to implement, that particular implementation I can be able to develop over here. Camera module shape, okay, and the location information. So I will be able to plan it. So this design planning will be for the chip level only. Okay, this particular design planning stage is for the chip level designing. That means area related implementation information will be decided for each block in the chip level only. We cannot randomly pick the area requirement. Okay, we cannot randomly pick the shape or the shape or area randomly. We cannot pick it, so it has to be provided from the top level only. Okay, next is that's why the next for a block level we will say is like import design stage. Okay, we will be saying it as an import design stage. That means we will be loading the required inputs for the PNR flow, or let's say PD flow. All the required inputs which needs to be provided for the physical implementation of the logic will be provided in this particular import design stage. So what all inputs to be provided, what are the contents present inside that particular inputs, we will be discussing during this particular physical design. Okay, advanced concepts when we go into the theoretical part. Okay, now the next concept is floor planning. Okay, in this particular floor planning, we are going to be performing is based on the structural information provided from the top level. Okay, based on the structural information provided from the top level, we will try to place the required physical objects. Okay, so that means like we have some terms here like die boundary, core boundary, and the spacing between this die and core is called as IO clearance. Okay, so these are the different terms. First, floor plan. Okay, now we are discussing about floor plan. It's like in the area provided, okay, in the area provided, we are going to be placing bigger circuits like RAMs. We will be calling this as like macros. Okay, macros are the bigger building blocks present in the design. That is, for example, like macros, memories, SRAM, DRAM, or processors. All that we will be saying it as macros. That means these are already developed circuits. We are going to be using it into our particular circuit. Okay, macros. That means like whenever you construct an house, right? The first and foremost is like what are the bigger rooms. You will try to construct that particular bigger rooms first and then decide about that particular smaller. Okay, how many rooms you want. In that, first you will try to develop the bigger rooms, and based on that particular area occupancy, you will try to next place the remaining logic, right? So it's the same case here also. Planning. Okay, floor planning means I'm going to be planning my base, or let's say that area of the core, to place the macros properly such that I can be able to place the standard cells, that is your basic gates. Okay, it can be either basic gates or a simpler circuits. Okay, standard cells are simpler circuits which will be having gate informations, full adder informations, multiplexers, demultiplexers, encoders, de-encoders, like that. Different circuits will be present inside this standard cells. Okay, so in this floor plan stage, we can say it's like creating core area, die area, creating the IO clearance, placing the macros will be done in this particular floor plan stage. Okay, so when we go into the advanced concept, we will be seeing is like what are the guidelines to place the macros and how to place it in the macro. That all we will try to get that information during the advanced concepts. Okay, how this particular die area is created, how this core area is created, on what factors it is you're selecting this much area has to be formed. Okay, that will be calculated during the detailed, or let's say advanced concepts. Okay, next is like power planning. Okay, the next step is power planning. In this particular power planning stage, we are going to be using a script. Okay, we are going to be using a script for the power distribution. Okay, we are going to be using a script for the power distribution. So if the power is not distributed properly, what will happen? If your house is not getting enough power, then what is the issue you will try to face? Guys, am I audible?
Yes, sir.
What is the issue you will face if you're not having enough power to your home?
It will not work properly.
Right, let's say like low voltage errors, right? I'm talking about low voltage cases. That means like your fan, which is going to be working at 1000 rpm, will be reduced to 500 rpm or something, so less, right? The speed of that particular every circuit will be working very small, or let's say very less. That means like again functional failures will pop up. Okay, functional failures will be coming. Okay, so that means like, so how that particular power distribution is getting done, what all supporting factors, okay, how to analyze that, we will try to observe it over here. Okay, one point to be noted here is, for this particular power distribution, okay, for this particular power distribution and also for this particular power analysis, we will be using a different tool. Okay, we will be using a different tool for that. Okay, as a PD engineer, you have to know the concept of that particular analysis structuring only. Okay, we may or may not be able to work in that particular tool. There will be a separate person to help you with that particular analyzation and how to fix us. Okay, that will be shared to you. You just need to use them. Okay, so you have to understand what are the reasons for that particular violation. If I have so and so, what all violations I'll pop up, that we will try to analyze it. Okay, only analyzation will be there in our particular structure. Okay, and the details and all, if you need it, we need a separate course for that. Okay, a power analyzation, so there is a course for that also separately, red hawk related, so that will be required. Okay, the what all information required for our PNR, or let's say physical design, that will be shared. So here I'm frequently using PNR, that means like placement and route. Okay, PNR means placement and route. So frequently we use this term only in the industries. So PD also we can say, but in mostly we prefer of saying this PNR, placement and route. Okay, so power plan will be provided, or let's say a script will be provided by a separate team, and we are just going to be sourcing that particular file. We are not going to be developing it. Okay, because there are multiple factors required for that particular development, so it will be taking again a lot of time. As we have only a short time, we cannot take that much amount of risk, so there will be a separate engineer for that as well. Okay, so that means you are going to be working in floor plan, placement, CTS, routing majorly. Okay, and also the power plant related sourcing of the script and the fixes provided by the equivalent engineer will be done. Okay, the next step is placement. Okay, now for this particular placement stage, where the remaining cells which are not placed in that particular core area will be placed. That means, for example, standard cells will be placed. While placing this particular standard cells, okay, while placing this particular standard cells, what all criteria to be followed, like timing, power, area, and how to reorder them, that will be discussed during the advanced concepts. Okay, so placement, placing the standard cells with the timing, on the basis of timing, power, and area, and how to adjust that particular placement to meet our requirement will be discussed during the advanced concepts. Okay, and the equivalent labs also will be performed. Next is CTS. Okay, CTS means clock tree building. Okay, clock tree synthesis, we can say. CTS means clock tree synthesis. So for the working of the sequential circuit, what is the dependency? What is the dependency for the working of the uh, sequential circuit? Guys, what is the dependency for that working of the sequential circuit? Okay, what is a sequential circuit? Guys, what is a sequential circuit? Yeah, flip-flop latch. So when you're talking about a memory element, a flip-flop, a latch, okay. So design will not work. Okay, sorry. A flip-flop or latch or a memory element. So that means the major requirement for that working of that flip-flop or latch is a clock, right? So the when that means I need to make sure like the clock needs to be propagated properly. Okay, the clock needs to be propagated properly. If it is not propagated properly, then what happens to the functionality of that particular chip? Sorry, functionality of that particular sequential circuit.
delay होगी, delay will come.
If the clock receives late than the data, then what will happen? It that means like there will be a data loss, right? The data before reaching that particular clock, let's say I have data and the clock is receiving late. Okay, at this particular edge, whatever that particular data is there, some so that means like if I'm receiving the clock at a different, so whatever the data which is present before this particular edge, that is lost, right? That data is lost completely. So my functionality will have a change. So that's why. So how to fix all that? Okay, how the clock needs to be propagated properly? What all factors has to be observed? Okay, that we will try to discuss in detail during the building of the CTS stage. Okay, during the building of this particular CTS stage, we will try to discuss each and every concept of it. Okay, what all factors we are depending on, that will be discussed. Okay, so the next is that means the clock tree will be built and the clocks will be propagated virtually. Okay, so that will be done during the CTS stage. The next step is routing. Okay, in this particular routing stage, okay, in this particular routing stage, we will try to route the nets physically. Okay, while routing that particular nets physically, what all the possible violations are there? we will try to analyze it, and we will try to fix them as well. Okay, clear so far? The overview of physical design and overview of ASIC flow is clear for everyone? Right. Now we will discuss about what all tools we are going to be using and also the technology nodes which we have. Okay, so the tools which we are going to be using is, for the synthesis, we are going to be using is design compiler, and next is like for the physical design we are going to be using is synopsis tool, that is ICC2. Okay, and for physical verification, okay, for physical verification we are going to be using integration of ICV in the ICC2 itself. And next for STA, that is like for timing analysis, we are going to be using is prime time. Yeah, so these are the tools which we are going to be covering so far. Okay, and the projects which you are going to be doing is in the labs. There are totally 2 projects. Okay, and in the labs you will be performing, that means like with respect to the mentor, one project will be done during your session hours, and one project will be given like an assignment to you, where the technology node you are going to be working is 28 nm and 14 nm. Okay, 2 projects, 2 different technology nodes. Okay, in the labs you will be working with 28 nm, and 14 nm will be your assignment project. Okay, that will be completely done by you only. Okay, so, and yes, so the tools are, let's say like when you're mentioning like industrial standards, we will not be able to have each and every license what the industry people will be having. Okay, but what is required for our learning, we do have all that particular licenses. Okay, so let's say like this is not any kind of hacked version or anything. This is like purely an legal procedure only. Okay, so I'm, because I'm not sure, like few might take it in a different way, so that's why I'm telling that in proper way itself. It's as per the laws only. There is no illegal parts over here, and we will be working as per our particular requirement. And here the flows will not be developed. Okay, we will just explain you all the concepts, and we will try to make you develop the flow. Okay, because in industry everything will be developed and you just need to source it. I'm just talking in a practical perspective. Okay, in industry everything is cleanly developed, you just need to source it. If there are any issues found, you just need to modify them. Okay, but in here we will try to help you in a level by level development. Okay, where you are going to be creating your own flow itself. Okay, that means we will try to help you with the scripting knowledge is tickle. Okay, basics of scripting knowledge will also be provided. Language of scripting, that is Unix and PCL, will be supported. Okay, clear? So the details of the project and how the implementation is done. Everything will be discussed during that particular starting of the labs and during that particular session hours. Okay, clear? So related to the theoretical concepts, or let's say related to the practical concepts, do you have any questions apart from the industry, let's say like administration? Any questions apart from this theoretical? Okay, so in projects there will be two projects. Okay, let's say like project 1 and project 2. Project 1 is a 28 project where you will try to do it in parallel with respect to the mentoring. Okay, and there will be one more project 2 that is working with respect to 14 nm. Okay, that you will try to do it in a self view. Okay, that you will try to do it in a self view. So that means there will be support only when you ask questions. Okay, 28 nm will be explained in detail one by one, and 14 nm you will try to do with the same task what was provided for the 28 nm. Okay, clear? Now, one second. Before going into that administration, let me cover off all this particular theoretical. So don't ask any administration questions till I say, because I want someone else to join and explain about that particular administrative questions. So that's why I'm repeatedly asking about this particular any theoretical concepts. Okay. So now two projects 28 nm will be parallel, and 14 nm will be done by yourself. Okay, while doing this particular project, what we will try to do is you will create your own scripts. We will not share you any kind of developed scripts. If we share it also, that will be like only for a reference. Okay, and also on a regular basis we will try to monitor the development of your scripts also, and we will give you some let's say advancement, what can be advanced and what can be modified. On that particular regular basis we will try to give you informations. Okay, and also apart from the flow, any other fixes also, let's say any manual fixes if you are doing, automation can also be helped. Okay, so this is related to the project. Is there any prerequisites? For me, there is no prerequisites. Okay, but as you are going as a fresher, the prerequisites will be CMOS knowledge, NMOS, PMOS, transistor, all this manufacturings, okay, second order effects, and how they're getting fixed. Only that information will be required. Okay, apart from that, and digital, analog and digital will be required. Okay, other than that we don't require much. Okay, so the total scripting languages available in the industry is Unix, Tickle, Perl, Python. Okay, majorly these four categories you have. So which you are familiarized, you can use that. Okay, majorly according to me we are going to be using is Unix, Tickle in a major part, and the next is like Perl and Python, you can learn it extra. Okay, Perl and Python you can learn it extra, advantage, added advantage in your resume. Okay, clear for everyone? Right. Now so now is there any theoretical knowledge you guys want to ask? is it like, if you want go ahead with respect to administrative questions, I'll ask one of our manager to join and he can be able to answer your questions. Yes, not purely industrial standard, but the fixes and everything will be with respect to the industrial standard. That's why I said we will make you to do. Okay, how the flow is getting developed, we will try to make you to do the similar method only. Industry is the same replication, we cannot do it, because what will happen is like each and every company has their own flow. Okay, so one will be doing with little bit iterations only, there will be a difference. So industrial standard, in the sense of how you are asking, I'm not sure, but I'll say is like all what you are developing will be a biggest step for your industry level only. Okay, what, how we are developing it, how we are fixing it, and again how we are redeveloping that particular scripts, that will be as per the industrial standard only. Okay, right. Okay, so I'll ask admin or manager to join the call, such that he can be able to help you with respect to the administrative questions. Yeah, Perl, Python, you have to learn it by your own. So we can, I'm not sure, but I think whether the institute is supporting or not. But Tickle, there is a separate course again for it. For Perl and Python, I'm not sure. I think so. There are some courses which are supporting. So that's why those questions will be answered by admin. So just give me 5 minutes of time. So let's make it like break of 5 minutes and back at 11:30. By that time, I'll ask the admin to join and they will answer your questions. Uh, Guys, just give us few minutes. Admin is trying to join. There is some kind of issue, so he'll be joining in just 2 more minutes. Just
Hello, Vishal.
Hi, Webber.
Hi. So, good morning, everyone. Myself, Vaibhav. I'm manager of VLSI Guru, looking into the training and the placements. So, I hope Vishal has provided you all the technical details about physical design, what are the things involved into physical design, as well as projects and the tools, as well as where you will be landing up after doing this course. Along with that, we will be also telling you about what will be the benefits of this course. Before that, any technical questions you are having?
Okay,
Yeah,
then
anyone
I
having
will be
query?
dropping off if there are no technical questions.
Yeah, that's right. So since Vishal is occupied by other meetings also, any technical questions, even what I will do is I will share my number in the WhatsApp chat. If you have any technical questions, you can get back to us. I will connect you with the trainer once again. Okay. So thank you, Vishal.
Yeah, thanks.
I will take this ahead and we'll discuss about the
Yeah,
placements also.
sure, sure. Thanks. Bye.
So is everyone able to see my screen?
Yes, sir. Yes, sir.
Yes, sir.
Okay, fine. So let's talk about the physical design. So basically, this physical design course will be a 6.5 months course in which we will be doing multiple modules. The modules, if I go to the syllabus, we will start a 2 months of basics or 2.5 months of basic trainings where we will include this VLSI design flow, semiconductor device fundamentals, advanced digital design, Linux operating system, PD flow, and then TCL. TCL is nothing but a tool command language. It is mandatory for the physical design candidate to carry out synthesis, STA, floor plan, power plan. So TCL is the mandatory language. Coming to next, then that it will be a 4 months of mains training. See, in mains we have this modules like synthesis, time constraints, UPF, NDM library, even placements, power plan. Multiple modules are there. For us or for the trainer to explain this with small examples, it will take hardly 1 month. But what we do is we will be doing two projects. As Vishal said, we will be doing a project on 14 nanometer and 28 nanometer technologies. So all these like synthesis timing conventions will be carried out in both the projects. Coming to what will be the timings and the course structure. See, the schedule of this training will be full week schedule will be Monday to Friday. Sorry, Monday to Thursday, 9:30 a.m. to 1:30 p.m. Labs and theory. The timing will be again the same. This is for the full week. Coming to the weekend schedules, many of you might be a working professionals or in your final semesters, so even they can opt for the weekends batch. When they if they go for the weekend batch, Friday will be off for the full week schedule, and Saturday Sunday will be theory. So you will be connected to the training institutes all 6 days for the theory and the lab sessions. Coming to the weekend sessions, the theory will be a common part, but after the theory there will be lab sessions that will be 2:30 to 6:30. Now this this is the full week schedule as well as this will be the weekend schedule. Coming to how the training will go. See, these all sessions that I have mentioned, the theory session or the lab sessions will be the live sessions, and every session will be getting recorded in the background. So, what is our expectation is when a candidate is attending the session, he should learn and clarify the doubts. Whatever the doubts he has, he will be clarifying the doubts. Now, we don't want anyone during the session to note down the things and simultaneously listen also. For that purpose, once you enroll for the course, we will be providing you the login credentials. This inskill.in is our e-learning portal where we provide you the login credentials. So if you enroll for the physical design course, this tab will be open to you, that is physical design. If I go over here, see this in this physical design, this will be the dashboard where there will be videos, schedule, presentation, assignments, notes, and labs. So if I scroll down, this unit 1, unit 2 are nothing but the live sessions that you have done over here. Like Monday to Thursday, whatever sessions are happening, that live session recordings will be uploaded onto this portal. So during the session of 9:30 to 1:30, you learn the things, you clarify the doubts. After a couple of hours, the session will be uploaded on your portal. Then you can watch it multiple times and revise or make up the notes. Every session that we will be doing, let's take an example. If you go for the theory session of Saturday Sunday, the trainer will initially within 15-20 minutes will invoke the tool and will demonstrate. Like for example, if he is explaining Floorplan power plan, he will invoke the tool, or even synthesis STA, he will invoke the tool prime time or even ICC tool and will demonstrate whatever 5 to 6 topics he is demonstrating on Saturday, Sunday, the same topic you will be doing the hands-on onto the tool. So on Monday to Thursday, 9:30 you will come, you will log in into the tool and you will do. Now there will be a live mentor to support you during the labs. Now, see, when the trainer is teaching you the topics or demonstrating you the project, it is not possible for him to discuss all the interview question. Will it be possible? Hello, am I audible to all of you?
Yes, sir.
Yeah, so let's the discussion go bi-directional where I can expect some inputs from your side. So see, basically when the trainer is teaching you the concepts and the topics as well as the projects, it is not possible for him to explain all the interview questions or what kind of interview questions can be asked with respect to any topics or with respect to any project. So for that purpose, what we do is we have uh, collected all the interview questions asked by the PD engineer into the assignments. If I go into the assignment tabs, with respect to each and every topic, the interview questions are uploaded over here by the trainers. So now let's talk about the placement assistant. See, the placement assistance is provided till you get a job. We have tie-up with 70 plus companies that include Samsung, AMD, Intel, Microchip, MediaTek, Analog Devices. Multiple companies are there. The package that you accept over here is for a fresher it will be going for 4.5 to 6 LPA. This will be applicable for service-based companies. Coming to product-based companies, it will be above 6 LPA. Now, for experienced people, it depends on their last down package, last down CTC, and performance in interview. So, the criteria for the placements over here is, since we have tapped with 70 plus companies, multiple companies comes to us asking for trained candidates. So when multiple companies approaches us asking for, please send us the good candidates or the trained candidates, we have a evaluation mechanism where after every module there will be a evaluation test. Multiple mock interviews, group discussions will be conducted during the 6 months of course. And minimum placement criteria is the assignments that I have shown to you, at least 70% of the assignment should be completed. See, anyone coming and saying, sir, I am well prepared, provide me the placements, I am not sure in which topic how much is prepared. But someone coming and saying, sir, I have completed 70% assignments, I am 100% sure that he have done through all the interview questions. Then we will provide you the placement assistance. So once you complete the 70% of the assignments, we will start providing you the placements opportunities. You don't have to look for the opportunities, or you don't have to worry about scheduling the interview. We will do it yourself. We will provide you all the details regarding interview, and we will provide mock interviews also. See, when it comes to placement assistance, majority of the company has 4 rounds of interview. That is written test, HR round, technical discussion, and then again HR round for salary discussion. So in the written test, whatever the assignments I am having, it is more than enough sufficient to clear the written test. When it comes to the HR round, HR is basically checking your basic communication, for which we conduct multiple mock interviews and the group discussions. Coming to technical discussion is something, it will be taken care by the technical team lead, or even team manager. So for that purpose, what we do is, when it comes to a technical discussion, he will won't be going for the basics. He will be directly asking, okay, what project you have worked on, or he will and ask what problems you face during the project. If you say that I didn't face any problems, then he will generate a scenario and I will ask you to debug. So in that regards, what we do is we align mock interviews with the industry trainers, where they will give all the details about what kind of interviews can be asked. After conducting this, there are 99% chances that you get placed. Still, you will not. If you don't get placed, we will support you till you get a job. Yeah. Any questions till now? Praveen, Rohit, Pankaj, Bhuvan, Darshan? See, I cannot say which is better compared to DFT and PD. Why? Because it totally depends on the requirements. Many times, what happens is DFT. Yeah, when it comes to DFT, there are companies who are having the DFT domain and they look for the actively hiring. Same with respect to PD. Now, if you ask me, on a scale of 10, 7 companies will have PD. But when it comes to DFT, it won't be more than 5 companies. On a scale of 10, I'm asking. So the people who are attending online or even offline, once they're done with their assignments, we will add them into the WhatsApp group. So online candidates will be also attending the will be also part of that WhatsApp group, as well as offline candidates, and we will provide you the link to apply. Okay, next is how much time people take to reach service based to product based. See, if things goes well within 1 year, it will be you can move into the service based. For example, if you go into a service based company called Capgemini, then you'll be working on the project of Intel. If you perform well over there, Intel can internally hire you into their team. And even every year there are requirements from the product based companies also for experienced candidates. If you hold 1 or 2 years experience and you can go ahead with that, definitely there are multiple chances. Even we have candidates who have, on the basis of 1 year in service based itself, they are gone into product based, and they are now team leads in product based companies. See, on a scale of since the recession is going on, the job openings in physical design earlier past 2 months back, there were very less hiring, but as of now, the hiring has increased. Now we are, I cannot say 100% openings are there, but almost 85% openings are there. See, one thing I would like to inform, that is, see, when recession comes, it won't come to one particular training institute. It will be coming to all. It will be recession will be coming worldwide. So what stands different to the VLSI group is, whatever opportunities are coming, we will make sure that it reaches to you and you apply for that. So answer to your question is yes. Still now we have almost 80 to 85% openings that are as of now coming. Even day before yesterday, we had a meeting with multiple companies where we are expecting this recession to be lifted up by this month end. The placements will start after 6 months of training. See, the placements are nothing but the candidate getting the expertise and then apply. So 6 months minimum will be required to get expertise. Okay, so since you have done the MTech in 2017, there are multiple ways for me to support you during the further placements. So as I had shared my contact number, please reach out to me on WhatsApp. I will explain you what are the multiple ways where I can support you. Yes, there will be a age limit where maximum age limit we can say around 35 to 37 is the age limit. Beyond what? Beyond that age, companies won't consider. Still, you can reach out to me on the institute official number. I am sharing it again. Yeah. So we can look into about how we can support you in the placements. Yeah. Any other queries? Arjun, Praveen, Puna, this one, Chandini. Your voice is not audible. I will request you to this one. Please put the message in the chat box. Okay, fine. So not only in this session, even if you have any more queries, we will be starting a batch from Monday onwards, that is tomorrow. If you have any queries regarding the course placements or even technical queries, we can even connect you with the trainer. You can reach out to the number that I have mentioned, either on call or through WhatsApp. Yeah. So that's all from my end. We will end the session here. Thank you, everyone.